Today we're going to be applying what we've learned about area and perimeter of polygons to the coordinate plane. Now, remember, the distance is given by this formula here. So the distance between 2 points x1 and y1 and x2, y2 is given as the square root of y2 minus y1 squared plus x2 minus x1 squared. Let's look at example 1. Graph the following set of points: -3, 1, 1, 6, 5, 1. Find the area of ABC to the nearest tenth. So let's start by graphing these points. So -3, 1, 1, 6, and 5, 1. Looks like here we have a triangle, and we need to find the area of that triangle. So the area is 1/2 base times height, and if you see here, the base has a length of 8, and this triangle has a height of 5. So this is 1/2 times 8 times 5, which is equal to 20 units squared. All right, let's look at example 2. Quadrilateral DEFG has vertices at 6, 1, 2, 4, -5, 4, and -1, 1. Graph DEFG and identify what type of quadrilateral it is. So let's go ahead and start by graphing. So we have 6, 1, 2, 4, -5, 4, and -1, 1. So what kind of quadrilateral do we have? It looks like we have a parallelogram. We definitely know that the top and the bottom sides are parallel to each other as they are right along the coordinate plane. But just to double check that the two sides, on the left and on the right, those are parallel to each other, we can just check the slopes. So it looks like we have a slope of -3 over 4 in both cases. So since the slopes are the same, we know that these sides are parallel to each other. So we would say this is a parallelogram. All right, now calculate the area of DEFG to the nearest tenth. So the area of a parallelogram is given by the base times the height. In this case, we see that the base is 7, and then the height, remember, must be perpendicular to the base. That would be 3. So 7 times 3, which is equal to 21 square units. All right, lastly, calculate the perimeter of DEFG to the nearest tenth. Now, in order to determine the perimeter, we know that we can find the top and the bottom sides. We actually used that base already, 7. But on the other sides, we're going to need to determine exactly what that distance is. Now you can use the distance formula, which really is just derived from the Pythagorean theorem, or you can go ahead and directly apply the Pythagorean theorem here. So if I draw this right triangle here, and I know that this side is 3 and this side is 4, well, if you know your Pythagorean triples, you know that this side is 5. If you don't know them, you can go ahead and do 3 squared plus 4 squared equals x squared, and that will give you 5 for x. So the perimeter is going to be 7 plus 5 plus 7 plus 5, which is equal to 24 units. Example 3. Polygon ABCDEF with coordinates 4, 0, 3, 3, -1, 3, -4, 0, -1, -3, and 3, -3. Graph polygon ABCDEF and identify what type of polygon it is. So let's go ahead and graph those points. We have 4, 0, 3, 3, -1, 3, -4, 0, -1, -3, and 3, -3. Since this looks like it has 6 sides, we would say this is a hexagon. Now, divide ABCDEF into smaller polygons that are on your area formula sheet. So since we don't have a formula for a hexagon, we're going to need to divide what we do have into basic shapes that we can find the areas of. So you can see here that we have this rectangular part in the middle, and we have these 2 triangular parts on either side. Now find the area of polygon ABCDEF by finding the area to the nearest tenth of each smaller polygon and adding them together. Let's start with the area of the rectangle. That would be base times height. In this case, that would be 4 times 6, which is equal to 24. Now for the triangles, we have two different triangles, so we're going to need to find the area of each one of those. So for the triangle that's on the left there, it has a base of 6 and a height of 3. And then for the triangle on the right, it has a base of 6 and a height of 1. So this is going to equal 9 plus 3, which is 12. Now that's the area of the triangles. So now we add the area of the rectangle plus the area of all the triangles, and that would be 24 plus the 12, which is equal to 36 units squared. All right, lastly, calculate the perimeter of polygon ABCDEF to the nearest tenth. So, to find the perimeter, we're going to need to know the measure of each side. Now, again, you can use the Pythagorean theorem to find the measure of those sides that we don't yet know the measures of. And since this is 3 and this is 3, that must mean not only could we apply the Pythagorean theorem, but we could also apply the fact that we have a special right triangle here. So if those two sides are 3, we know we have an isosceles right triangle, which is a 45, 45, 90 triangle, which means that the hypotenuse is going to equal 3 root 2. So the perimeter would be 4 plus 4. Now you can do the same thing with the triangle on the other side, 3 squared plus 1 squared, and you end up with square root of 10. So square root of 10 plus square root of 10 plus 3 root 2 plus 3 root 2. And that gives us that the perimeter is 8 plus 2 root 10 plus 6 root 2. And that's equal to about 22.8 units. Example 4. Find the area of ABC if it has vertices at 1, 3, 5, 2, and -3, -3 to the nearest tenth. Let's go ahead and start by graphing those points. So 1, 3, 5, 2, -3, -3. So we have a triangle here. Now this triangle is going to be fairly difficult to be able to find the area if we try to find the base and the height of this triangle. However, one way that we could go about finding the area of this triangle is we can draw out this rectangle on the outside so that we can subtract some right triangles, of which the base and the height are easy to find, in order to determine what the area of this triangle is. So here's the rectangle that includes the entire triangle, and then we're going to subtract out some triangles on the corners. Let's start by finding the area of this rectangle. So the area of this rectangle is base times height, so that would be 8 times 6, which is 48. And now let's find these triangles and subtract those out. So this triangle over here would be 1/2 times 4 times 6, which is 12. This triangle here, 1/2 times 4 times 1, which is 2. And this triangle here, 1/2 times 8 times 5, which is 20. So now we can subtract out the 12, 2, and the 20 from 48, and that will give us the area of the original triangle ABC. So 48 minus 12 minus 2 minus 20, which is equal to 14 units squared. So the area of that triangle in the middle that we were originally trying to find is 14 square units. All right, example 5. Quadrilateral ABCD has vertices with coordinates 1, 4, 2, 3, 0, -3, and -3, 1. Graph ABCD and make a plan for calculating its area. So let's go ahead and graph those points. So we have 1, 4, 2, 3, 0, -3, and -3, 1. So we have a quadrilateral here, and let's come up with a plan to calculate the area. Now we can do something like we did in example 4, where we can find the area of the larger rectangle that includes this entire quadrilateral, and then subtract out the right triangles from the corners. Alright, so let's find the area of each of these triangles. So this triangle area, 1/2 times 4 times 3 is equal to 6. In this next triangle, we have 1/2 times 1 times 1, which is equal to 0.5. In this one here, we have 1/2 times 3 times 4, that would be 6. And here we have 1/2 times 2 times 6, which is equal to 6. So now we need to find the area of the larger rectangle. That would be 5 times 7, which is equal to 35. And then we can subtract all 4 of those triangle areas from 35. So this would be 35 minus 6 minus 6 minus 6 minus 0.5, which is equal to 16.5. So the area of quadrilateral ABCD is 16.5. All right, the last thing we're going to do is calculate the perimeter of ABCD to the nearest tenth. So for this perimeter, we're going to need to know the measure of each of these sides, and we can do that by using what we know with right triangles or using the distance formula. So here, we know this side is 3 and this side is 4, so we know this side must be 5. Here, 3, 4, 5 as well. Now over here, we know this is 1 and 1, so we have a 45, 45, 90 triangle, so we know this is going to equal the square root of 2. And then in this last triangle, we know this side is 2, this side is 6, which means that 2 squared plus 6 squared, that's equal to 40. So the square root of 40 can be simplified to 2 root 10, so this side here is 2 root 10. So the perimeter is going to be 5 plus root 2 plus 2 root 10. And there's no way for us to combine root 2 and the 2 root 10, so we could just say it's 10 plus root 2 plus 2 root 10.